Okay, so at the beginning, I'm just repeating this because I needed to record it real quick. At the beginning, you might need to pause to get all of this, but we graphed y equals x squared. We made a table of values and we graphed the points, and the shape is a U shape, which is called a parabola. So we're going to turn the page and we're going to see vertex form, what that looks like. Okay, so vertex form looks a lot like one of your forms for absolute value. Okay, so remember when we graphed absolute value, the a was on the outside, it was x minus h inside the absolute value, and then plus k on the outside. So this works exactly the same, and this is called vertex form. It's one of the forms for quadratic equations. Remember for linear equations how we had different forms? We had standard form. What was another form besides standard form? There's point slope form, and there's another one. What was that y equals mx plus b called? Yeah, slope-intercept form, right. So there are 3 different forms for linear equations, and we're going to really be talking about 3 different forms for quadratics, but today is all about vertex form, which is good because it works exactly like absolute value. All right, so if you have a vertex, the vertex would be h comma what? K, yeah. H comma k is your vertex. And so h is the x-coordinate and k is the y-coordinate. And so when I'm looking at something like this, you want the opposite of -4. So that would be what?
4, 5.
4, yep, and you want the same as the other one. So same here. So 4, 5. And then our a value, there's no number in front. So how much is the a?
1.
It's just 1, yeah. The a is just 1, so it means that there's no stretch. Okay, to draw the parabola, you start at 4, 5. But we're not going to draw a V shape. We want to draw the parabola shape, right? So let's look and see what the difference is. In the parabola, we still go over 1 and up 1. But when we go over, from the vertex, when we go over 2, we don't go up 2. How much do we go up? 4. So it's over 1, up 1, and over 2, up 4. That's the parabola shape. Instead of having the same like over up that you have from the V, you go to the vertex, over 1, up 1, over 2, up 4. So let's see how it looks here. Over 1, up 1 on both sides. Then go back to the vertex. You're back here, and you go over 2, and you go up 4. Don't start at your new point. Start at your vertex. Go over 2 and go up 4. So this was at 5, I'm going to go up to 9. All right, it's really easy for people to get those points wrong because they're always trying to start from here instead of starting from here. So from this point right here, that's where I counted over 2 and up 4. All right, so if you did it right, it should look like this more rounded U shape. So I see what you're saying, like from this point, it's over 1, up 3.
Yeah.
But what I'm really counting from is this point. So from down here, it's over 2 and then up 4. Okay, axis of symmetry, it works exactly like it did for the absolute value. It's still this line here, so it still starts with x equals. X equals, and it's x equals what?
4.
4. Okay. Who has a question on that? It's okay? Axis of symmetry is this line that goes through the middle of the parabola. And it always starts with x equals because it's a vertical line. And then you just look to see what does the x equal. Okay? All right, so I need to tell you what these examples are down here. And I want you to try them. But make sure you're using a pencil because you just learned this, so it could take a minute before you have it. So the first one is going to be y equals x plus 2 squared minus 4. And then I'm going to have y equals negative x minus 5 squared. And y equals 2, x plus 1 squared plus 3. Okay, so I'm graphing those three right now. I'm going to give you guys a minute to try them, and I'm going to come and answer questions that you have. Remember, though, that we're always using this pattern, so we should always get a U shape and not a V shape. Okay, for the first one, did you get -2, -4 for your vertex?
Yeah.
And there is no stretch. So when there's no stretch, it follows the parent function in the pattern. So you got your vertex, you go over 1, up 1, over 2, up 4. The next one, you had your vertex at 5, 0, because there was nothing here. And the -1 flipped it upside down, but it was still the same pattern, it was just flipped. So it was over 1, down 1, over 2, down 4. And then this one, you had -1, +3. And a lot of people try to do this as like a V shape. After they go over 1 and up 2, they keep trying to go over 1, up 2, over 1, up 2. But that's going to make a V shape, and that's how you know that's not right. So over 1, up 2, but then when you go over 2, instead of going up 4, you have to go up twice as much, so you go up to 8. Any questions? I saw a lot of you got that. That was really good. All right, let's turn the page. All right, this next page is weird because the challenge problem comes before the easier problems, but we're going to do it anyway. So just remember, if this one here seems tricky, the normal problems are coming up after it. This is the challenge, this is normal. We need to come up with the equation for this one. And the problem is, it's not over 1, down 1. It's also not over 1, down 2. Like, it's some fraction, and it's going to be really hard to figure out what that fraction is. So we're going to figure it out with algebra. Okay, we're going to write down the equation, y equals ax minus h squared plus k. And we already know the vertex. The vertex is your h and your k. We need to figure out the a. So the way we figure out the a is we plug in for h and k, and we plug in for x and y. This point here is 1, x, and y. So you put all those numbers in, and you should be able to solve for a. So for the y, put -1. I don't know the a. For the x, I'm going to put in 1. For the h, and for the k. All right, so that's a lot. Minus negative is the same as what? Plus. So 1 plus 2 is 3, and then I square it, and I get what? So -1 is equal to 9a plus 1. Subtract the 1. -2 equals 9a. And we're going to get our fraction now. Which, see, I would never have guessed it was -2/9. I might have said like -1/4, -1/3. Never would have guessed that. So that's what my a is. So when I put that back in the equation, I have y equals, instead of a, -2/9. X, what's my h again? -2. So instead of minus -2, I'm going to put plus 2. Don't forget the squared. And then plus my k. All right, so that was kind of tricky. That was kind of a long problem because you had to find your a, then you had to put it back in there. But down here, did you see how this one's over 1, down 1? And this one's over 1, up 1? And this is over 1, up 1? So for all these problems, the a equals what number? 1, yeah, for all of these problems, the a equals 1, so you don't have to worry about it. So all you have to worry about is plugging in the h and the k, okay? So I want you to see if you can figure out the equations for all three of these. Y equals, figure out what goes in there, okay? For number 1? All right, so if it's not stretched, then your a is just 1. Although in this case it's flipped, so what do I have to do? Exactly. So you don't have to worry about finding if your a is 1. You Okay.
Oh, so we don't have to plug in extra line.
Right, you don't have to do all those extra steps. We do that if it's not an easy A value. Okay. All right, so for the first one, the vertex was back 2, which is +2, and up 1, which is +1, and the negative flipped it upside down. For the next one, the vertex, this is your H, and this is your K. So if I'm plugging into this formula right here, I have y equals x minus h, so that would be minus -1 plus 1, and then minus 2. And if there was a stretch, it would go right here, but since it's over 1 up 1, there's no stretch. So you could put a 1 here if you want, but you don't have to. This one, y equals, what's this going to be, x plus or minus? Goes to the right, so what should that be? Minus, good, x minus 3. And then do I have anything here? No, because you could, you could technically write +0 because it doesn't go up or down, but it's best to just leave it, the +0 off. All right, what questions do you have before you go to the next part? Remember how I told you there are different forms for quadratics? That's what's down here. So this is standard form. Intercept form has 2 sets of parentheses, and vertex form has 1 set of parentheses. This is the one we've been doing today. But you just need to recognize what form they're in, okay? So on the bottom here, 1 through 6, I just want you to write standard, intercept, or vertex, okay? If it's standard form, intercept form, or vertex form. So take a minute to try those down there. All right, so the first one has 1 set of parentheses, so that means it's probably which form? Vertex, very good. And then we were just talking about number 2, it has no parentheses, so that means it's standard form. What about number 3, what's that? Intercept form. And this one? Standard. It has an extra number here for some reason, that's weird, but it is standard. Number 5. Vertex, wait, I think it has too many parentheses for vertex. What is it? Yeah, intercept, good. And last one? Vertex, good. Okay, so the reason why you need to know what form they're in is because there's a different method for graphing each one. So you want to be able to graph all of them. But if you get stuck, how can you always check your graphs? In the calculator, yeah. You can plug the graphs in the calculator. So even though you're learning 3 different ways of graphing, if you're not sure if you're doing it right, just check it on the calculator. Okay, turn the page, one more. This is just getting us ready for next class. We're just reviewing a little bit of multiplying algebra. So the first one, I'm going to do the examples for you. I have this one, and there's one more down here. This one. So I'm going to do the 3 examples, and then I'm going to give you guys some time to work on the rest of these here, okay? So distributing is just 2x times x, and remember that if you multiply x's, you get x squared, so that's 2x squared. And then 2x times 10 is 20x. And then FOIL is one method for multiplying 2 binomials, but it's not the only method for multiplying it. I also like to think of it as distributing. So basically, you start by distributing the x. X times 2x is 2x squared. And x times 9 is 9x. And then I distribute the -5. So -5 times 2x is -10x. And -5 times 9 is -45. So first I distributed the x, and then I distributed the -5, and the last thing I have to do is just combine my like terms. So these two can combine to make what? 9x minus 10x. Is that more or less than 0? Less than 0, right. Negative 1. It's negative 1x and then minus 45. So that's your final answer for this one. Okay, and then my third example is down here. Let me tell you that there are calculus students who think that the answer to this is x squared minus 49, but you guys are not going to fall for that. It's not x squared minus 49. Because you're not allowed to take the squared and distribute it. Squareds don't distribute. What you do want to do is when you square something, you multiply it by itself. So you want to multiply x minus 7 times x minus 7. Okay, so I promise you'll see problems like this where you have something, a binomial squared, and half the kids in your class will get it wrong because they think you square each part. Instead, you're going to do the same thing we did up here. X times x and x times minus 7. X squared minus 7x. And then negative 7 times x and negative 7 times negative 7. And combine like terms. So x squared minus 14x plus 49. That's your final answer. Okay, so I'm going to pause for a minute and I'm going to give you guys some time to start working on all the number problems, starting at 1, going all the way down to 7, and I'll come and see if you need help. Alright, so check over your answers. Let's see. Make sure that for each of these that you have the right, like you have no x and you have x squared and x, you have x squared and x. Down here, make sure you combined your like terms correctly. This one gives you 10x and this one gives you negative 7x. Do you guys have any questions through number 5?
So this
No.
is the unit?
Say it again?
Like this is
The new unit is quadratic functions, and actually it used to be a really long unit, but you know how hard it is to take a test on a really long unit? Last year we cut it in half. So now it's kind of a short unit. There's only 4 days of instruction before you have a review day and then a test. But it's the first part of quadratic functions, and then we have a second part of quadratic functions after that. But quadratic functions are these ones that make the parabola shape. So we're going to be doing a lot of graphing, and we'll probably do some of the stuff where you write equations. We'll be graphing all 3 forms. All right. Down here for the squaring, let's check your answers. This one I got x squared plus 8x plus 16. And this one 36 minus 12x plus x squared. Okay, so I'm going to stop this.